welcome back to my YouTube channel. Today we will talk about covariance and correlation and how we will apply this concept if there are two variables and if we want to know if they are correlated to each other or not. So we will explain through a small example, which is through Mira, who runs a small kirana shop in her colony. Every festival season, more customers walk in, but her nephew Ravi, who learning data analysis, asks her a sharper question. He asks, when more people come in, does the sales grow proportionally too? Or sometimes more footfall but less sale, despite over the more people coming remain the same and low. Not the same, sorry. So the question is, do the two sets of numbers move together and how strongly? Mira doesn't know. She never actually measures it. That's exactly the question, and that's exactly where the covariance and correlation comes into the play. So by end of this video, you'll know how to calculate both in Excel and more importantly, how to read that number, what is telling you. So there's no intuition, no formula yet. What we gonna know is find the averages. Average daily footfall, how many customers are coming in, average daily sales across the data. Check each day if the average is above and below. If the sales is above and below average, we will look for the pattern. Do the above average day line up with the both, like both the if the customers are coming more, if does the sales also grow? Same days, both average, both variables if going up, that means there's a positive relationship. And if the same day, both customer flow over and the sales, both if there's no customer, no sales, negative. High customer flow, low sales, negative relationship, and no consistent pattern either way, little or no relationship. If we have more flow of the customer and the more sales, positive relationship. More customer flow or no sales, negative relationship. And if there is a inconsistent way or no consistent pattern, nothing is there, that means no relationship. This is the covariance formula. I will show you the workbook how we calculate in the Excel. Just this is the covariance formula between two variables, and we will be doing the sum of, if we have number of data is number of size of sample is 10, we have 10 data, so each one of the variable we will subtract it from the mean of the average, and then other variables same, we do the sum of all this thing and divided by the number of the values we have. So how far today's footfall is, how many customers coming over from the average footfall, and how far today's sale is from the average sale, average the result across all the data points. And plus and minus tell you the direction, doesn't tell you the strength. Units are messy, people and rupees. So you will come to know when we are doing actually on the workbook. So these are the formulas we'll be using to calculate our data in Excel. This is the long way, so each value to the average. Like if it's a, we can change this formula according to our data in the cell. So this is the A2, it is the one variable. If let's say for example a footfall, X variable to the mean of that footfall, and B2 is our sales value, so each value to the average of that sales data. So sum of the all rows and number of phase overall covariance. Now this fast way, when you use is equal to covariance dot p. What p suggests is we have entire population that's divided by n, and S is assuming the data is sample of our bigger population, that's slightly more conservative. And so if we have 10 variables, a small positive covariance means the both values are moving together, they are strong positive relationship. But number alone doesn't say how strongly, so that's where a correlation comes into the come into play. We will come to that later. First we will learn what first we will how we calculate covariance in Excel. The workbook, we have this raw data of the Amira Kirana shop. So we pull up the data, 10 days data from Amira's shop diary, daily customer count, daily sales. So now we will find the average customer count for those 10 days and average sale. And each day, was the footfall above or below average? Was the sales above or below average? If both are above and below, both are above on the same day, both below on the same day, so they are moving together, so that means there's a positive relationship. If there's a high customer flow and tend to have a lower sales, negative. So when it's a bigger crowds, they're just doing the window shopping, so it's a negative relationship. Covariance is just an idea, and we made it mathematical, and each day multiplying how far is the customer flow from the average, how far is sales from the average, so that's, and divided by the number of the values, that is the covariance. But this tell you direction, right? And the but the number itself doesn't tell you what is how strongly it impacting the two variables, how these two things are moving together, how much we don't know, how positive, how strong it is. First come first, how we calculate it. We have this data, we what we did, this is the customer footfall, is number of the customers coming into the, so day one 42 customers and sale is 4100, and second day there is what we have is 38 customers, but sales are increased. First, x variable and the minus average of that x variables from day 1 to day 10. Day 1 itself variable, so this is a C7 minus the average of whole this thing, and y is the y minus average of whole this thing. Now we multiply both things, and we have covariance, if we want to calculate manually, divided by the number 10. So we have this value. Built-in Excel formula, covariance population, that's the entire population. We have this formula is equal to covariance dot p, both the values C7 to C16 and D7 to D16, right? And this is the covariance on sample formula. This is the correlation formula, but what correlation, why we need the correlations, we will talk about this later, right? And now, so up till now we know if for this customer flow and sales come out small positive covariance, they are moving together. It's a, so now comes to the correlation part. We calculate the covariance. Now correlation. To understand correlation, we have this covariance and correlation rate. So this, next door Mehta family runs a mithai shop with the 4 products, which is laddu, barfi, jalebi and namkeen, and they want to know how every pair of product relates. Does the jalebi sales spikes come with the barfi spike too? Are they related, unrelated? So how we can calculate this? We have this day 1 laddu sales data, barfi sales data, jalebi sales data and namkeen sales data. So we calculate the covariance. How we calculate this covariance? We, instead of running for the formula 4 times manually, in the top left we can drag across and down, locking one x as absolute and letting the other move, right? And this is our covariance dot s c7. This is a both value absolute because we want, if we want here c7 is absolute. But how we can do, if we make one value absolute, another value keeps on changing. So I, in this, in another, I make c, this c value absolute because we want c to remain as it is and want what, the other value which is not absolute keep on changing. So c, d and e and f, c, so c remains same, the absolute value remains same and the other value keeps on changing, right? And in this value what we make, d as absolute and c, the rest, the c's remain same. So c remains same here, d remains same in each here, and here it is, e remains same all down, because only need to change is just this one column and make it one absolute and one reference value. And then if I delete this, okay, because we applied this formula, we select all the 4 cell and drag this to another 4 cell, we have this value. So this is c value to the d value, and you can see this both columns, if it's laddu same, burfi and burfi same. Now laddu and burfi in this 14.64 and laddu and burfi to this column is the values are, our formula is correct. We don't need to apply the formula to the each cell, right? So here you can see burfi burfi and jalebi jalebi and namkeen namkeen. So they has the positive correlation, that's why we have a positive values. Now Rafi's issue is covariation, the number itself nothing says, is it strong, weak, we can't tell, okay? And correlation, in a correlation, same core idea, but we have the result sits between 1 or -1. +1, it's a perfect lockstep, like customer flow up, sales up every single time. 0 is no relationship at all. Negative is saying we have more customer flow and sales down every time. For Mira Shop, we have a correlation is approx 0.69, which is a very strong positive relationship. That number is actually compared because it's between plus and -1, that across the shop, across the products, across everything, anything that gives you the number between plus or -1 that you can actually compare. So now the question is that value, is the what we have 0.69, is it actually reliable? Could it be a coincidence? Is not a random noise? So this is where a significance lookup table comes in, right? We have a sample size of, what sample size? 10 values. We have 10 data points. Now we have a confidence level of 90%, 95% and 98%, right? And we have a correlation is 0.69 that clears the bar. 10 sample size, 0.69 that clears the bar of 95 confidence, because for the 98 it requires 0.71. It clears the bar of 95% confidence level, not the 98%. That means 19 in 20 chance, there is a 19 in 20 chance this relationship is real, not a random noise. Solid. So takeaway is, when we have the more data days, more confidence in your number. So this is a start. This is a not a verdict, but a start. You can say yes, there is a correlation between two values. This is a, we can tell these two variables are moving together. If you're comparing products, these are okay. There's a relationship between these two products. If okay, let's say when we're comparing this, correlation is okay, laddu barfi has a positive correlation, and but laddu jalebi has a negative, there's negative correlation. Namkeen and laddu has a positive correlation. So correlation is what shows up every time that you, what diversification in there. You will have a more grasp of this concept when we talk about the stocks in the next video. When the fund manager look for stocks with a lower negative correlation, if one drops, does it the whole thing, whole portfolio, whole whatever you invest in the stock, whole thing drops? We'll come to know in the next video that explain you at what exactly when we know the correlation, how diversify it. The you can see the diversification in your data. So whether you checking with the Mira, her shop, or analyst checking for a fund, do any of the two numbers move together? Can we trust this pattern? So there you can have answer. You have your two variables. If you want to compare the fourth thing, for two variables or four thing, you can apply this covariance and correlation, and you can check. If you have a correlation, that always give you a result between plus and minus, and you can tell how confidently how this is the data is not a random. We have okay 95% confidence, they very strongly, this is a correlated, just like in this example. When we have a correlation of 0.69, that's between sits at 95% of the confidence, how much it's positively correlated to each other, the how customer flow and sales impact each other variables, right? The concept of the correlation that always gives us the result between plus and minus 1. And we look into the Excel file how we can calculate the correlation between the four different products. And we built one formula, log 1 axis absolute with the F4, drag across, so down the grid is symmetric. Laddu to Burfi always equals Burfi to Laddu, same trick, scales. And that stock thing, we will talk about this thing to explain the diversification in your, to check if there is a diversification in your data. So we also talk about what the problem with the correlation number is. Doesn't tell us is it strong, weak, you can't tell, right? So that's how the correlation fix this. Same thing, same core idea, but the value, just we have always plus minus 1 and minus 1 number you can compare across anything. So this is the correlation formula. In Mira's case, we have a correlation number is 0.69, which is a fairly strong positive relationship. And now a number you can actually judge. So negative correlation, one rises, other tends to fall. No correlation, two are essentially unrelated. Positive correlation, both tend to rise and fall together. So we also understands when we're talking about if it's meaningful, this correlation value or not. If the relationship real or coincident, then we check through this is correlation coefficient significant stable. In this case we have a sample size of 10 data sets. We have a value of 0.69, so that clears the bar of 95% confidence, which need 0.63, but we have a value of 0.69. To clear the value of 98% confidence, we need 0.71, but we don't have this value, so this explain it clears the bar of 95% confidence. More data, more confidence in the number. So 19 in 20 chance this is a really real relationship, not random noise, not a coincidence. It's meaningful data we have. So beyond this correlation, we can also check diversification and stock market, that we will explain in next video. Whereas we need both covariance correlation, we will check the diversification concept in next video. So yeah, we will see you in the next video. Hope this covariance and correlation clicks for you. Hit for like, subscribe and comment, and see you in the next video.